Welcome to our first section of work, which covers basic engineering drawings. Now, you might wonder why we start off with engineering drawings. Well, the reality is whatever component you're going to be dealing with in your engineering career is going to normally have to be defined by some sort of a drawing. And that drawing needs to be universal across the world, and it needs to be understood by people who speak various languages. So it must not rely on the written word to describe the object. Rather, it must rely on a means of drawing or sketching that component. And there are many ways to sketch a component, as you well know, but normally a 3-view drawing or a 4-view drawing in certain cases would well describe a component. And by 3-view drawing or 4-view drawing, it simply means you draw the object from 3 or 4 different directions. And what's also important is the orientation of those various drawings that you make from the various directions are placed on your page in a certain way in 2 different types of projection: first and third angle projection. Now, in the case of this little motor car, it's obvious what is the front and what is the back and what is the top and the bottom of the car, because we know what a car looks like. But if this was a more complex component, not known to you, then the actual position of where these were, coupled with the knowledge of what type of projection it is, would tell you a lot about that component. Now, to describe how it works, we do use the example of a small toy car, and we're going to start with the first angle projection. And I want you to picture the little toy motor car placed on your desk such that you can see it the way it is drawn over here. In other words, you are looking at the left-hand side of the car. Now we start with first angle. Now, for first angle, you need to memorize this little statement over here, which says, what you see on the left, you draw on the right. So back to our little car. If you were to walk around to this side and look at the motor car from this direction, look which way the little red pointer is going, what would you see? Well, you would see the front of the car. That drawing would look as follows. And according to first angle, you must place it to the right of the car. So what you see on the left, you draw on the right. So there's our little motor car. What you see from the left-hand side, you draw on the right-hand side. And vice versa. So what you see from the right-hand side, which would be the back of the car, you would draw on the left-hand side. And similarly, what you see from above, you draw below. So looking from above, you would see the top of the car. Where do you draw it? Below the car. That is called first angle projection, and the projection symbol for that looks as follows. Here it is here. This depicts a little bucket, as we call it, or a frustum, and the way these two are orientated reminds you of the first angle projection. What you see on the left would be 2 circles, the inner circle depicting the top of the frustum and the bigger circle depicting the bottom. And what you see from the left, you draw on the right, and that is first angle. So engineering drawings are either drawn in first angle or third angle projection. So one of the first things you must look at when you are given a drawing of a component is to look for the symbol, either this one or this one, to know whether it is drawn in first angle or third angle. And using that information, you're going to know more about that part when you consider the position of the various views in relation to each other. Now, while we're at it, let's do third angle. It's just the opposite way around. What you see on the left, you draw on the left. So back to the motor car, what you see from the left would be the front, you draw it on the left. And what you see from above, you draw above. So what you see from above would be the top of the car. Where do you draw it? Above. And the third angle symbol says exactly that. What you see from the right, you draw on the right. So if you were standing to the right of this frustum, you can see the small circle is above, which indicates that it is standing with a sharp point towards you. If you looked from this side, you would see exactly this picture here, which would be drawn with this orientation. So what you see on the right, you draw on the right. Right, next I'd like you to consider this object over here and try and memorize what it looks like. Let's try and describe it. It has a base, and the base has a little piece cut off the front here, which is going to end up with these two hard lines when you draw it. And then it has this piece sticking up, which has a hole through it, and there's even this little fillet over here. Right, so remember that component. Now we are given that component drawn with three views, which they are naming front view, right side view, top view. But even if you didn't know or have those titles, if you were asked to identify the projection method, in other words, to figure out whether this is a first angle setup or a third angle setup, how would you go about it? Let's go back to the object. If you were to look at this object from the right hand side, now by that I mean if you were viewing it from this direction, let's draw a little arrow from this direction towards the object, you would see those two hard lines. If however you were looking from this side here, let's draw a little arrow from this side here, if you were positioned over here and you were looking at the object this way, you would certainly not see that hard line over there. You would simply see the rectangle, which is the end with this piece sticking up. So with that in mind, if we were to draw this object from one of the sides, be it from the right hand side or the left hand side, only from one of those would we see the hard line I spoke about just now. And you can see it over here, there's that hard line. So it stands to reason that this view is in fact in agreement with what they've said here, that is the right side view. So if this is the primary view, the main view, and you were to view it from the right hand side, you would see that. And because what I looked at from the right I drew on the left, it is which type of projection? Can you remember? It's that one, first angle. So far we think it's first angle. Let's check with the top view. If you were to look at this object from above, in other words looking from here downwards, what would you see? Well, you would definitely see this piece sticking up, which would not be the case if you looked from below, but if you're looking from above you would see this piece, and there it is there. So this view does appear to be the top view. It is viewed from above and it is drawn below. So what I see from above, I draw below, is which type of projection? Let's check. Not third angle. What you see from above, you draw below. It is indeed first angle. So we've answered the first question. We have identified that the projection method is indeed first angle. So what you see here is a first angle projection of the object in question. Next we must insert the projection symbol. So you simply choose this or this, and it's got to be drawn somewhere on this drawing. And there are no other variations of the frustum. It is either in this orientation or this orientation. Okay, so to answer that, that would be the solution. There is the symbol for first angle, and that is the orientation of the three views. Out of interest, had it been positioned or drawn in third angle, it would have had to look like that over there. So have a look at that. That doesn't answer the question, but it's just to demonstrate what it would have looked like had it been drawn in third angle projection instead. Right, now here is another task for you. Example 2, you are given an isometric sketch. That is what this is over here, an isometric sketch. And from it, you must generate a 3-view drawing in third angle projection. And you must take the view from the lower left corner as the front view. So from the lower left corner of your drawing, if you were standing here and looking at the object in this direction, we will make that the primary view or the main view, front view. Include the correct projection symbol. Okay, so all the dimensions appear to be here. There's a hole all the way through over there, and there are all the other dimensions given to you. So you are given an isometric sketch, and from it you must make a three-view drawing in third angle projection. So I want you to take a piece of paper, stop the video now, and make a good attempt at that before carrying on. So hopefully you've made an attempt at it by now. Let's have a look at the solution. If you were down here and you were viewing the object in that direction, let's think what you would see. Well, you would see, in my opinion, the full silhouette of the object would be a large rectangle. In the distance you would see the hole all the way through. You would look right through the object, and you would see a hard line over here, and you would see a hard line over there and over there, which would be depicting those edges. That edge and that edge would be visible to you. You would see nothing extra in the background here, because that hard line would be directly behind that hard line, and that would be pretty much all you would see if you were viewing the object from down here. Okay, now the big question is where to place that view in relation to the others. Well, we were told, first of all, that is the primary view. What did they call it? Let's have a look here. It says take the view from the lower left corner as the front view. Okay, so that's going to be the front view. So I'll even write front view for now, because that's our starting point. But now where do we place the other views? Well, if we were to draw a top view, that would be looking from above downwards. Let's first decide what we would see. And I'll just draw it in any arbitrary position. Again, I would see some form of rectangle, but the rectangle would have a cutout at the front here. And I would see a hard line over there, and viewing from above I would not see the hole, so I would have to show it as hidden details. There'd have to be a dotted line there and there, and we could give it a center line to indicate that there's a hole there. Was a good idea for any hole feature. But now where to place it? Well, we've got to draw in third angle, and third angle says what I see from above I draw above. So back to our primary view. If we have this as our primary or front view, what we see from above would be what I've just drawn. We would have to draw it above over here. So it's a simple matter of positioning this piece, this feature, directly above the front view. So that would be the orientation of those. So the top view would go above, and the view from the right, if I choose to draw that one, I would have to draw on the right. So what I see from the right would be exactly this. There's the base sticking out to the left. There is hidden detail showing this recess, this cutout. Here's hidden detail showing the hole feature that is going through. There's the center line, which we always use when we have a circular feature such as a hole, to indicate where the center of that hole is. So there is the layout of your three views of the object in question in third angle projection. So here's another example. Once again, an isometric sketch. Now, by the way, when we talk about isometric sketches, it means that the isometric sketch is one that has a 30-degree angle down here. So if you look at this, it would be 30 degrees, and on this side it is also 30 degrees. So all isometric sketches are drawn like that. Okay, but anyway, we are given the isometric sketch, and we are told to generate a four-view drawing. And we are also told to take view A as the front view. So start off by drawing view A, exactly what you would see. In other words, if you were looking from this point towards the object, what would you see? Draw that first on your paper in some arbitrary position, and then draw a further three views of the object orientated correctly in relation to that first view, and you've got to do it in first angle projection. So go back and look at the rule for first angle projection, and stop the video now, and then let's look at it. Let's proceed once you have finished that. So view A would be the rectangle. Remember, I'm viewing from the direction of this arrow, and on top I would see the cylindrical portion sticking out upwards, and on the left hand side I would simply see a rectangle depicting the block. Next I'm going to draw another view. Let's pick any arbitrary one. Let's go and position ourselves over there and look downwards at the object. What would we see? Well, if you were above the object, you would see the circle, and behind it you would see a rectangle, probably a square in this case, and you would see this bit sticking out. So let's draw that. I'm going to draw it in any arbitrary position down here. I would see a circle, I would see the square or the rectangle, whatever that is, and I would see this bit sticking out to the left. So that is what I would see if I were positioned above the object looking downwards. Okay, now where to place that? Well, first angle projection says what I see from above I must draw below. So it is what I saw from above, so it must be positioned below down here. So I'm going to shift it into that position below. So that is the correct orientation of the view from above, or the top view. In first angle it must be drawn below the primary view or the front view. Next, let's do the view from below, which would have to be placed above. So the view from beneath, if I were to be positioned over here and look at the object from below, I would not see the circle because it's on the other side of the object, so it would have to go in as a dotted line. And it would have to be placed above. First angle says what I see from below, I draw above. So it would be this view and it would be positioned above. And then what I see from the right, I must draw on the left, and that is evident by the dotted square that you see over there. And vice versa, what I see from the left, I draw on the right. There the square is not dotted because it is visible to you if you are positioned on the left hand side. So there are your 4 views of the object. Now in our next example, we start to see the benefits of understanding first and third angle projections. And the example is, if you were given a single view of an object, such as the one over here, from it you certainly cannot draw the object or visualize the object, should I say. Especially this bit sticking up. Is it the full width of the whole object? Is it less? Is it positioned at the back of the object? Is it positioned at the front of the object? It's hard to know. This hard line here might well indicate a cut-off corner, but we don't know enough about it. If, however, we are given a second view, or possibly a third view as well, but if we're just given one other view and we are told what projection it's in this case we are told first angle, we can, from just these two and the words first angle or the symbol first angle, we can actually visualize the object completely. Now, to illustrate whether you can visualize the object completely, I want you to try this example, number 4. From the first angle views given, these two, generate an isometric sketch of the component depicted. So you've got to go exactly the opposite to what we've done so far. Up till now you were given an isometric and you had to come up with various views. Here we are given just 2 views in first angle and we must generate the isometric sketch. So once again, stop the video here and make an attempt at that. First step is to set up 2 construction lines, both at 30 degrees to the horizontal. Okay, so by that I mean, if this is your horizontal, that is 30 degrees and that is 30 degrees. You have to start with that. Vertical lines are still vertical, so that's not a problem. So that is going to be the corner of our isometric. Next I'm going to draw the back face of the object, and it has some thickness. So let's do that. And I haven't cut off that front corner yet. I'll do that last. And we have a raised line over here. And the object ends about there. and it goes back. Now we must make sure we still stay at our 30 degrees, and we have the raised portion with the hole in it, which is not quite at that point. We can go all the way to the back. I'm going to be doing a bit of deleting of lines that I can't see in a moment. Here's the bit that stands up at the back. Remember, this is a sketch, so I'm not drawing it to scale at the moment. This is just a sketch. And we have the curved portion on top. And we have a hole. But now that's the back edge of the raised portion. Here we're going to have a fillet. I'll draw that later, but let's just draw it as a sharp line for now. And we have the raised portion front edge, and we go down to that point there. Just tidying up matters a little bit over here, and I got rid of the bits that I can't see. Okay, that's looking a bit better. Over here I'm not going to be able to see that, so I'm going to get rid of that bit. Nor can I see the bits behind. This line can go. That line can go. This line can go, but it must stay across here because you see the hard edge over here, so that must stay. But this bit you won't see, so let's get rid of this bit over here. And you won't see that. Tidy up that edge, that bit's not there. Get rid of my construction lines. Where I set up my 30 degrees, that can go. This bit can go, that was a construction line. Right, two things missing. We need to chop off this front corner. So let's draw in, let's estimate where that cutoff is. Once you've cut it, you would have a hard line there and a hard line over here. And of course you would have the hard line where the cut was. And we can erase the bits that are gone now. Something like that. And the last thing to do is the little fillet, which would be looking something like that. And you would see an edge there. It's debatable whether you would see that or not. I'm going to draw it in for now. And in the distance, this bit would not be visible to you because it's inside of the fillet. And this bit would not be visible either. And the hard line would simply end over there. Let's just tidy things up a little bit better here. That's better. Okay, so let's zoom out and have a look at that. That's a reasonable sketch of the object. It's somewhat out of proportion, but after all it is just a sketch. There is a sketch in better proportion of the same object. But that is the basic principle of making an isometric sketch from 3 views or 4 views or 2 views in this case of an object, or from the object if you have it in your hand. So to conclude this section of work, here is a slightly more complex example to end off with, and you're required to generate a 3-view third angle orthographic sketch of the component shown. The 3 views must be A, B and C, so in other words looking from this way, and this way. And A must be the primary view or front view. Include dimensions and hidden detail on your views, and here's the important part: to fully define the component, and you must put in a projection symbol. So to fully define the component is vital, because if you were giving this to somebody to manufacture, they would need to be able to manufacture it solely from the information you've given them, and they shouldn't have to contact you for further information. So that's how we check if that's been achieved. If you want to visualize the object better, if you can't visualize it from this isometric sketch, here is a link where you can look at a few CAD views of the object from different directions, if that's going to help. but essentially it is an angled bracket with two holes through it and a slot on the underside which runs all the way through. Okay, so once again, pause the video and make a very good attempt at all of that, and make sure that you meet all the requirements of the question. Right, so here's the solution. There's your front view, and there are the other two views positioned correctly according to the projection symbol, and of course all the hidden detail, center lines for circular objects such as the holes, and a bunch of dimensions, and you can spread them out across the three views so that you fully define the part, but you don't clutter one view with overly many dimensions, so you can spread them out. And that is a typical mark allocation for such a problem. So 25 marks, 10 for the dimensions, 3 for the neatness, and 2 for each of the views being correct. Also make sure that you go and look at the suggested links that are in the document, this one and this one, on the first page, and then later on in the sectioning part, here is another link which you need to work through, and so that you don't have to type those in, you can get the links from the notes that are given to you as well. There you can just click on the link there. But anyway, the last section which you need to work through on your own is the matter of sectioning. And sectioning is when you need to show detail of a part of the object which is clearly hidden to outside view because it's inside. And you can do so either with a full section or a half section or a part or scrap section, as they sometimes call it. And a full section would be, for example, this object here, where you want to show the detail that exists inside the object. So the way it works is you make an imaginary cut through the object, and then you show where you made that cut, in this case on plane AA, which is shown by putting those two arrowheads up against that chain dot line there. And then in the correct position, you draw what you would see if you were to cut through the object on that plane. So the piece on your side has been omitted, and all that you see is what's in the distance. And now there's the matter of the sectioning lines, which you can see as the scratch marks left by the saw that did the cut, the imaginary cut. So if you were to cut through this object, discard this piece, turn it so that you could actually view it from the bottom, in other words from this direction, you would see what's left over here, and these hatched lines would indicate where the saw had actually cut through the material, and the hard lines show the shape that is visible to you once you have now cut into the object. If you feel that only half of it needs to be sectioned, then you can do it with a half section, so you keep the one side intact and you just section the other half. Or you could even go in and just show that you are taking a section through a small portion, leave everything else intact and just section there, and show where the saw would have cut to do that. But I do suggest looking at these links that I've provided you, as they are quite useful. So to summarize, we've learnt about three view drawings: first angle projection, third angle projection. We've learnt about making isometric sketches, and we have a rough idea on how sectioning works once you work through all of this. And hopefully with all of that, you can then understand basic engineering drawings to a level required for your career in mechatronics engineering or renewable energy engineering as a higher certificate